The beauty of this operator is it allows you to distribute your particles over any max object. So let's have a look at it in action. I'll just turn off this position icon flow and turn on position object here, and I'll just scrub back to frame 0. Okay, let's have a look at the actual parameters for this operator. Now, unlike the icon operator, the position by icon operator, you have to have an object for this operator to act upon. So in this case, I've picked this geosphere here. Now, what this actually does then is it distributes the particles over the sphere. So we'll just turn off the speed operator here, and we'll let the particles emit. So there you can see the particles are actually emitting onto the surface of the geosphere. So that's pretty cool. You can see, like the position icon operator, that there's a lock on emitter, and there's also an inherit emitter movement. These become much more useful in this respect because now you're dealing with a mesh that can actually animate. Now that means basically this could be the skin of a character. You could have a character's hand and you could emit these particles over it, and then when the particles are moved by the hand animating, the particles will actually lock to the surface and will inherit the movement from the surface. So at this point you'll have particles locked to the surface and they'll be inheriting the actual speed given by the surface. But of course they'll still be locked to the surface. So what's the advantage of this? Well, you can then test the speed of those particles, and if they exceed a certain speed value, then you could pass them to a new event and they can actually fly off into space. So in that way you can have a character that actually shakes his hand and water droplets will fly off it. So you can see it's pretty useful. So let's have a quick run through of the parameters before we have a look at it in any more detail. So as with the object icon operator, we can turn on lock and emitter. And now if I scrub the timeline, you can see that the particles are birthed, positioned on the geosphere. And then as I scrub the timeline, you can see they're actually locked to the geosphere. So that's pretty cool. If I turn off lock and emitter and turn on inherit emitter movement, you can see that the particles are birthed, they're positioned on the icon, on the actual mesh. Then as I scrub, the particles which were actually birthed during the period that the sphere is moving, they inherit its motion. So it's exactly the same as the position icon operator in that respect. You can see that you have the same value in terms of a multiplier for how much motion is inherited. You can put that down to 0 and you won't inherit any motion, which is, you know, the same as having the operation turned off. You can use negative values, so it'll inherit negative motion. You know, the particles will travel in the opposite direction. And you also have a random value, so you can actually vary, in this case, the amount of motion that's inherited from the actual mesh. So there you go, that's pretty much exactly the same, apart from the variation value. So we'll just put that down to 0, and we'll turn off inherit movement. Move back here. And as I said, you need to pick a mesh for the particles to be positioned on. This isn't actually exclusive to one mesh, it can actually be a list of objects. So if I actually scrub forward so all the particles are emitted, well, nearly all of them, the majority there. And if I create a new object, let's just create a cone quickly. There we go. You can see I can actually add this cone, and now some of the particles which would have been positioned on this geosphere, they're now shared out over the surface of this cone. I'll just delete that cone and remove the item from there. So you can see it's also very cool in that you can actually distribute your particles over multiple objects, multiple meshes. So that's also a very useful feature. You can also, you know, remove the particle objects as I just did or you can add by a list. So you can actually add a lot of objects in one go. Directly below the emitter objects window, you can see you have animated shape. Now, the use of this option is vital on deforming meshes. If you've got any kind of mesh altering modifiers, such as a bend or skin or flex, then this option must be used. It makes particle flow resample the shape of the mesh over time, and this ensures that the particles are positioned on the actual surface at that point in time. If lock on emitter is actually used, this will also ensure that the particles are actually locked to the surface of the mesh. So let's actually show that in action. We'll turn on animated shape and we'll scrub through, and you can see at the moment it's not really having any real effect, apart from the fact that the particles are being positioned here, the ones that are actually being birthed during this period that the mesh is moving. So you can see it's having a little bit of an effect. The actual distribution of the mesh is being updated. That's because it's looking at the mesh on each individual integration step and determining the position of the particles based on the mesh at that time. If we, however, turn on lock on emitter, you can see that the particles are now fully locked to the mesh. But there's no real difference with that, is there? So if we scrub a little bit further on, you can see that the mesh now starts to deform. I've actually got an animated noise modifier on the mesh. So you can see it's producing a sort of rippling motion. And you can see that during the rippling motion, the particles are actually locked to the mesh. So that's pretty cool. Now, this is, as I said, is vital if you have a character, because a character's mesh will be skinned, and that's a kind of mesh deformation. So you have to make sure that you have lock emitter turned on a deforming mesh, and you also have to make sure that you have animated shape turned on. Otherwise the particles either won't be positioned correctly, or they will actually be left behind when the mesh deforms, when it actually travels through space. So you can see that's actually pretty cool. The next tick box is subframe sampling. And what this will ensure is that the actual animated shape is sampled between frames, not just at the end of frames. And this gives you a much more accurate animated shape actualization. So in certain circumstances it may become necessary to actually use subframe sampling, but as ever with most operators, it actually does cause a slowdown. So only use subframe sampling when you really need to. This may be needed, for instance, if you're noticing any kind of lag on the particles, that they're not actually following the mesh as closely as they could do. This could possibly be caused because they're not actually evaluating the mesh between frames. So that can be a vital feature in certain circumstances. It actually improves the quality of your particle positioning. But as I said, it does slow things down quite a lot, so you have to be careful with that particular option. As with the position icon operator, you also have options here for choosing how the particles are actually distributed over the target mesh. You can see we're using surface at the moment, and that works in the way you would expect. You can see the particles are randomly distributed over the surface. And you can see you actually have quite a few other options. Pivot will distribute the particles over the pivot of the object, and as you can see, the pivot's at the base, so it doesn't really have that much use in this particular instance. Let's move on to vertices, and this actually limits the distribution of the particles just to the vertices of your geosphere, or whatever measure is that you're using. Now in this case we've actually got quite a lot of vertices, so I'll just go down here and reduce the face count of our geosphere. There we go, and you can see now that the particles are actually just emitting and being positioned just on the vertices of this particular sphere. So you then have edges, and as you can imagine, the particles are emitted just on the edges of our sphere, which you can see here. And you can also limit it to the surface, as we've just seen, or we can emit particles into the volume of the geosphere. As you can see here, they're actually being emitted inside the sphere now. And you can see that